All right, so we're recording. So welcome to our CCNP class, ENCORE class on 420 of 22. Today, I wanted to mention something to you. I was doing the lab 2813, and we're going to kind of walk through it a little bit, which is using NetMiko Python module to configure a router. And one of the things I immediately noticed is that hidden in this setup is a file for the switch, and I forgot to put that pre-config into the files that I gave you. So if you go do lab 2813 and you only drop in the router config, it's not going to work because the switch, the correct switch ports don't come up. Now you can just bring all the switch ports up and it will work fine. But I've also inside of Canvas loaded for you or put into Canvas the pre-config for the switch for lab 2813. So if you are working on that one, have noticed that the switch wasn't configured correctly. The reason is I forgot to put the pre-config in there, but they kind of hid it on me in this document, so I missed it. But that has been fixed. So you basically end up with, in this particular lab, as you can see, there's a PC with it's going to have a CCNP VM that's already preloaded with idle Python NetMikos inside of that you need. And then the router itself, you put onto it DHCP and some other items. So what I want to do is actually just real quickly run through this lab because it is a little bit confusing in that it uses a built-in VM that is on the inside the PC itself. So one of the first things you have to do is, of course, load the pre-config for R1, all right, which we did here, and then load that config for the switch. You'll notice the only thing it's really doing is bringing up G1011 and G1023. That's all you need to do on the switch. So you really could just bring up all the interfaces. By default, when it comes up, though, those interfaces were down on this lab. So it was not, I couldn't get it to ping from the PC to the router. So I was getting a little bit aggravated with that. But what we're going to do first is on the PC, there's a special thing here that is actually Pcx Virtual Machine. And this Pcx Virtual Machine is a Hyper-V machine that is a special VM. You just double click on it and then click start. And it's a special VM that it really, quite honestly, is basically a version of the DevNet VM that we have that has Python preloaded and idle preloaded on it. And so you just let it boot up and then it bridges itself through Hyper-V, through the bridged interface already on the PC, and it is able to get an IP address from the router because the router is set up with a DHCP pool using the config. So if you go up here and look at this config, you'll notice there's a DHCP pool excluding all but 1 through 10. And so it's pretty easy to see what we're doing with this. But this is the one place that's a little confusing when you go to log into this PC on using this special Hyper-V. They used a weird username. They used student, and they used the password of student pass with capital S and capital P. And that password is nowhere else in anywhere in the CCNP stuff we've done so far. So just pay attention, read the documentation because it can get away from you if you're not careful. The next thing you need to do is on this Hyper-V PC is you can either do an IP address to find out that you got an IP address, or I just pinged it. So just ping the 192.168.1.1, which is the IP address of the router. And as long as you can ping the router, then you'll be able to do the rest of the lab. So we go down through here and we got that. So they're going to test PuTTY connectivity from inside. Now remember, this is from inside the PC that is this virtual PC that's running in Hyper-V. So this is really neat because if you think about what we've got going on here, we have a virtual machine in ESXi, which is this host PC. And then we've got another virtual machine in Hyper-V inside the virtualized, it's almost like, well, it is. We've got a virtualized machine inside a virtualized machine, which is really kind of neat. But make sure when you're doing this step 4 and it says open the PuTTY SSH client, you're not opening it inside the PC out here. You're opening it in the Hyper-V PC that you've started up using that special PCX virtual machine. Hey, Nick, how's it going? Nick, I made a quick comment earlier on this lab 2813. There was a pre-config for the switch. I forgot. Oh, I didn't see it. I didn't see it in the documents because it wasn't real clear. So you don't have that in those the zip file I gave you. So I put it inside out here so it's available for you for the pre-config to fix that problem. So I don't know if you've done this lab or not.
I have not done that one.
Okay. So we've opened up the virtual machine from Hyper-V in here. Now we've proved we can ping. We're going to see if we can SSH from inside the Hyper-V machine to the router. And this is going to be important because this is how we're going to use NetMiko to connect over from this virtual PC into the router itself. So we're logging in as Cisco with a password Cisco 123 bang. I think I mistyped the password. Yep. Felt my finger hit the wrong password. Now we see, so show Ipm Brief, and I've already played around in here, so you see I've added a loopback of loopback 52, but we're gonna do that here in a second. We're actually gonna do some things with NetMiko and Python. So the first thing we're gonna do is we're actually going to open up idle. Oops. We're gonna open up idle. And we're going to open our environment and we are going to create a new script. All right, so we're going to do file. Actually, we need to first import NetMiko. So let's import NetMiko. Get that imported and running. Then we're going to file, new file. And we are going to create, in fact, I'm going to put this in here again, but import NetMiko. And then we're going to create a script. And what we're going to do, this script is actually going to connect using Python over to our router, so over to R1. And you'll notice what we're doing here is we have to send it using this connect handler function. We're going to send over information on how to connect to the device. So first thing we're going to do here is, and you got to follow this exactly. If you don't follow it exactly, it will not work. And this is pure Python. So you know, if we don't type it correctly, it will not work. So you got to type in the okay, connect handler, then device type. This tells it that it is a Cisco iOS device for the connect handler function equals Cisco _ iOS. Now, if this was an NX OS device, we may have to change this. I honestly don't know off the top of my head. If any of you played a lot with the programming, you may know that, but depending upon the device, iOS should work for most of the Cisco devices that we work with. Now we're going to put in the IP address of that remote router, which is at 192.168.1.1. We're going to tell it what port to go to, which is going to be SSH. We're going to give it a username, and this is the username that we have already set as a local username on that device. And then the password, it's going to equal Cisco 123 bang. And then we're going to end our script. Okay. Now we're going to save this. So we'll just save as. I'm going to save it as NetMiko, which I've already run it in here. I'm going to rewrite it. Okay. And then we're going to run it. And if it works correctly, whoop, we got something wrong. That's because I should put, yep, needed a space in there. So let's hold on. So more than likely, this is my problem right here. So file, save, run my, nope, I got something else wrong. Oh, I got it. Notice what I forgot to do, folks. I forgot to import my function. Okay. So we've already imported NetMiko. So I need to do a from NetMiko import connect handler. Without this, I don't have the function to actually then run the connect handler function. So I forgot that. So let's go back and save it and let's run it. Now we should get that. Now notice that's actually what we're going to get. And it's not going to give us any output right now because we didn't tell it to do anything. We didn't tell it to give us any output. We told it to come in and connect here, but we didn't tell it to actually do anything. So now we're going to have it get actually complete a command. So we're going to complete a command and have it show us something from inside of the router itself. So let's open NetMiko, our script again. And now we're going to have an output. So we're creating a variable called output. And that variable is going to be the output of SSH CLI command send underscore command. And the command we're sending is going to be show Ipm Brief. Now notice I was about to make a mistake because I need double quotes in here instead of single quotes. Okay. And then now, so what we're doing is we're connecting via SSH to the device using the username and password. Now we're going to ask it to give us the show Ipm Brief command and store that as a variable called output. Okay. Now it's going to be pretty ugly when we do this, but let's go ahead and do it. File, save, and let's run this. And so now using Python and the connect handler, we're going over and connecting, and we're running the show Ipm Brief. And we're going to now see that from output, you can see that we've got information, but that information is very poorly formatted. So what we need to do is we need to set up a print command that will format this information in a way that is more readable than what we've got here. So now we're going to go back to our exact same script. And now we're going to put in print. We're going to tell it to print. Okay, make sure I'm doing my double quotes. Print, double quote, squiggly, squiggly, backslash n, double quote, dot format. And basically what this is doing is making the format into a more readable, putting spaces in the correct format that we need in order to make this readable. So now we're going to run it and watch what happens. Now we should get something that's almost exactly what we would see from a typical show Ipm Brief. So with a script from this machine sitting over here, we've sent an SSH connection over to R1 using Python connect handler, and we've issued the show Ipm Brief command and pulled that information off of R1 and displayed it on the PC. Pretty cool. Now, instead of just doing that, now we're actually going to make an interface. We're going to do more than just look at something. We're actually going to send a command over to create a loopback interface. Okay. So now we're going to do config. Actually, I'm going to change this just a little bit. I'm going to put this at the end. And I'm going to go up here and put our config underscore commands equals, and we're going to bracket. Okay, we're going to create int loopback 101, and it could be any number, but I'm just doing 101 colon, and then we're going to do IP add of 100.100.100.101. Okay, 255.255.2. Oops, can't type. 255.0. All right, and then now we're going to put in a description. Now, don't get confused by this description. What they're wanting you to do is this. It's, if you read it, it makes sense, but the description needs to be just your name. And so I'm just going to put KFC, KFCs, and that slash, make sure that the comma, this single quote here is not being, the single quote is not being read as a single quote. It's being seen as apostrophe instead of a single quote. Loopback. If you didn't put that backslash there, it would see that as the end of the line and would give you an error message, an error. And then we have to get this sent config. We have to create a variable to have the config actually get sent. So SSH CLI dot send underscore config underscore set. So it's telling it send a configuration using config underscore commands, which is what we just created above. So this is saying send via this SSH CLI send command set the commands inside of the item we put above. Now, if all's hunky-dory, I should be able to save this. I should be able to run it. And here in a few seconds, we should actually see the output and see that Loopback 101 has been created. And there it is. So what that Python script just did is it actually sent the commands to create Loopback 101, apply the IP address to it, okay? And then we printed the show Ipm Brief command. Now we could continue on and do a whole lot of other things here, doing the other items that they want us to do as far as just showing, but this is using, you send an erroneous command, send a bad command, it will tell you that you get a problem output. You know, basically it says you've got an error at this particular, or it overlaps with a particular one. But this is the entire config, or the entire Python script used as part of this example. And it's very simple, but this is a basic example of software-defined networking. Take this and scale it up to the point to where all of your devices are being controlled by a DNA center. And you have the concepts, at least the base concepts of controlling your network with a centralized SDN type controller. But even more so, when we talk about SDN and software-defined networking, you can even get to the point to where the switches themselves have very little control plane ability, and the control plane actually exists in a controller, which is a very hard concept in some ways for us to understand, but it is a neat way to see that you could actually run different feature sets and features on that controller. Question
Kelly?
about, yes.
Would that controller be similar to like a wireless controller?
It's very similar to the way a wireless, you know, and in fact,
in the theory, anyway.
yeah, exactly. In the theory, where you've got the wireless LAN controller sitting in the background doing control plane items, and you've got the AP in the front doing more of the data plane items. That's very similar concepts to the way that a fully software-defined switch works.
Yeah, because I'm watching you do this, and I'm thinking, if you're just SSHing into the device, why don't you just use TerraTerm and go direct?
I agree, but let's imagine this. Let's imagine we had 400 routers and we wanted to push config change out all 400 at one time.
Right, and that's where the control plane comes into play.
Exactly. That's where you're really getting into the ability to make large scale changes.
Yeah, but that's not what we're seeing with this. So I guess it's much harder to wrap my head around firing off those commands to multiple devices at one time when we're just looking at it one instance at a time.
The other thing I want you to think about is this now, and this wraps kind of all of our security ideas and things together at the same time. Let's imagine that we have in the background a DNA center that all of our devices are connected to. So let's imagine instead of this being a PC, it's a DNA center. And integrated in that DNA center is ICE, Integrated Identity Services Engine. And also we've got, let's say, what's their Talos, it's their security product, and other items in there. Let's imagine that this switch is connected to that. And through this type of concept, as soon as a machine is plugged in that has a virus on it, and that is seen, then you can immediately force that switch to change its configuration for that port into an error disabled status or into a VLAN that's a remediation VLAN. And then it forces them to, or they don't meet a certain policy. Let's say you're looking for antivirus version 4.8 and they're on 4.7. You could force them into a remediation VLAN and make them go upgrade their antivirus before they can get on your network completely. That isn't another kind of use of this type of concept. I know this is a very simple example, and you could very easily do what we're doing with TerraTerm. I just think it is kind of neat to see that using pretty simple Python scripts, you can affect, just about anything. You really can. If we think about the config commands, and I don't know all the commands that are available inside that config commands, but pretty much if we could configure it from, let's try something. Let's try this just for grins. Let's see. Let's try.
Could you go and change the password for each device? So if you had 100 devices and needed to update passwords,
you should be able to, yeah. Router OSPF1. Okay, and let's do network 0.0.0.0.255. I'm trying to remember. Let me think here. Okay, and then let's do this. Let's try this and just run it and see. It may not work, because I don't know if that's actually one of the config commands that are supported through NetMiko, but looks like it may work. It didn't automatically dial on us anyway.
So with that NetMiko, it automatically pops up as in the configuration, in the global configuration mode.
Yep. Now let's do this too. Let's do okay, so we got that. So instead of this show Ipm Brief, now let's change this to show IP protocols. So file save run. We're probably going to get an error message here, but well, we may not. It'll just overwrite it because it's not something that overlaps. Look at
There
that.
it is.
Yep, there it is. So it shows you that with that, we just configured OSPF for all networks on that router. So that, really, I would say, I would guess, and again, I'm assuming, what that does sometimes, but I would guess any command that you can make at the about failed there. Any command you can make at the command line, you could issue through that config command, which is that's pretty cool. Especially, you can imagine if you had if you wanted to suddenly change, or add areas on a bunch of routers at one time, or change a bunch of your networking at one time, you could push this all out. Even a small environment with 10 to 15 routers, it would be very simple to do this. Someone,
So
George, have a question?
You can connect to multiple devices with just this one command.
Yep, you should be able to just do this SSH CLI connect handler and just put in a new one for every device that you're connecting to.
Just another instance for each device.
Correct. Let's try it here. Let's really push the boundaries, folks. Let's go.
You should be able to loop through and change what the host is.
Yep. Let's try this. I didn't actually drop the config command into this one, but let's try something here. Let's do config T. Let me go back up and look at the switch or the router config, what they got in here. They've got, so let's do host S1 IP domain net or domain Cisco.com crypto key generate. And I can't type, y'all. RSA 2048, just for poops and grins. Username Cisco, password Cisco 123 here. Oh, we need to get privilege level 15. Notice that is one of the things, that's one of the reasons why we're able to do what we're doing, because that user has privilege level 15, which means they have admin privilege level when you're SSHing in. So that is a key item there. that they're doing. Where my username go at? Where's she at? There it is. Okay, so yeah, we do have privilege 15. All right, good. So let's go to drop that. Int VLAN 1 IP add is 192.168.1.2 255.0. No shut, even though it should not be down anyway. Okay, so line BTY 015. Login local. Transport input SSH. All right, so now we should be able to, from this, first things first, let's test to make sure we can ping it. Oops, let's open a new terminal. So let's ping 192.168.1.2. Yep, we're good. So we can ping it. So what we should be able to do, and again, I am not a programming expert, so one of you may have to help me through the programming here, but we should be able to actually open up. Let's go back and open idle again. And we could just click on idle there, but let's open it. File, open. We should be able to actually just change this connect handler and change it to 1.2. And all that's the same. And then we're, instead of this commands, we're going to drop this out first. Let's just drop this out a second. Let's cut it just a second. And what we're going to do is we're going to do show Ipm Brief first. So file, save. Let's run it and see if we can connect. Yep, there we go. So we just connected to the switch. So yeah, it's the same thing. So we could just connect to the switch, and then like you said, if we wanted to, we could, we should be able to actually run through and make it do a series of, we can make it connect to 1.1, 1.2, and then continue on through and run commands and send commands just to individual pieces as we wanted to do it. So yes, we could definitely do that.
So you can just create another instance of the connect handler right there, and it would go in and do the show IP interface brief on both.
Yep. In fact, if we should be able to do actually this, if I'm not mistaken, let's try this. This should work. We do a control V here and just change this back to 1. And then file, save it, and then run. And let's see what happens here. It should show us the output of both. First, it should show the switch, then it should show the output from the router. Nope, it only showed the bottom one. And that's because my programming skills suck. There is a way to do it. Let's see. In fact, here's how we would do it.
To say, I think you're going to have to name the second one not SSH CLI, make it SSH CLI 2, and then.
Yeah, you're right. I think you're right.
Name.
So yeah, name them 2. And make this the same 2. And that should work, shouldn't it?
That'll work, but it's doing 2 instances. You're not just running one instance. Well, I guess
I got you. I see what you're saying. Yeah, I'm running 2 instances of connect handler. I got you. Yeah, you should be able to, the connect handler should have a way of, well, I know it does. You should be able to feed into it multiple. In fact, I think
there it is.
There it just did it. It did both of them there.
Yeah.
So it fed out both. But yeah, you should be able to actually in the connect handler. I don't know how to do it with. I don't know how to do it. The syntax for it. but I know what you're saying. Yeah, you should actually be able to, inside of just this connect handler, be able to feed it two different items and say it that way. But that actually did work there too, making two versions of this SSH CLI and having
Yeah,
that function run.
Two different variables.
Yep, two different variables, make it output that. But you know, that's really neat to be able to show your students that and have them play with it. To continue, you know, to be able to make the devices do what you want them to do based upon the scripts.
This would have been good in DevNet because it didn't really explain the link between passing APIs and networking.
Right. Now, some of these labs are supposed to be in this lab right here. It was at one time in the DevNet class, or something very close to it, because you were using the 1000V to connect to it and do this lab. So I know that was close to it, but to me, I really like doing it on the real gear and seeing it actually, because you can go over and look and see it connecting to the real gear.
Mm-hmm.
You know, it's actually connected to the VTY or TTY session, and can see what's going on. And, you know, go over here and do a show IP Pro 2 and show that, you know, we've added OSPF to this device. And, you know, it's really, really cool. That's one thing I didn't do. I could have changed the router ID. That would have been a good thing to do inside of OSPF. But so pretty neat little lab out here on 2813 inside of NetLabs. So a good lab to do, good little lab to play with, good lab to goof off with and make some changes and see what you can do and actually touch, you know, go into the switch. Remember, the main thing we had to do on the switch to make it work is we had to just set up a local user. We had to set up our crypto keys, and we had to set up SSH into the VTY lines. Without those, it would not have been able to work. So again, we set up just a username with privilege level 15. That's very important because without that, when we SSH'd in, we would not have been able to run all the commands that we were running. We would not be able to get into basically privilege exec mode. This drops you in as privilege exec mode, as being in enable mode. And then down here at the bottom again, a lot of stuff going on, but we basically, all we did was put in an IP address on the VLAN and assigned SSH as an input method on our V2I lines with login local. So pretty cool stuff in this lab. Pretty simple example, but a great example showing you how you can do these types of things inside of a router and switch. Any questions? Well,
yeah, it's interesting.
Yeah, I thought it was really neat. It's a fun little lab, I think. Now we've got a couple other labs here that you've got. I'm not going to do them right this second, but but inside of here, you'll notice we've also got a couple more labs, and we did that's the one we just did, and then we've got netconf using the iOS XE device. So it is very similar to what we just did, but we're using netconf instead to do. And in fact, notice, let me see if I put the switch into that one. I think I forgot to do the switches on every one of these. Yep, I did. On 28.1.4, I'll post the switch, and I'll post the switch for 28.1.5. I messed all three of those because I did not see the switch. It's the same config. So I'll just copy it and make it the same. So that one's the same. But you use that VM again, and you're using, in this case, netconf. So you're going to turn on netconf inside of the router, so it can actually talk netconf, and then you're going to connect to that netconf using the CCNP VM that's on the routers, or excuse me, on the PC's main page. So getting into XML, showing you XML code and things you're going to be seeing. So I'll fix that other one. Sorry about that, y'all. And then finally, you're going to use RESTconf to do the, you know, really a lot of the same things. You're just looking. This is using Postman. So this is using what you've already done. This is most definitely a lab straight out of DevNet. So you're taking Postman and through Postman doing requests out to the device to gather information off of the router. So see how it's filling the body section and pulling out all the information. So here's a get Python script with a get request, import JSON, import request, and then you're going to do through an API using REST conf, you're going to request the information about the interfaces that are on the device. So just multiple ways of doing the same thing. We did it with Python just through the connect handler and sending command line interface information. So let me fix this right here. We're going to copy this. Actually, see if I can copy it. Copy to, nope. So I'll just have to do a couple of them. I'll do a couple of these. So I have to fix this text. So sorry about that. I'll get that fixed for you. Any questions about that? Any questions about where we're at with the class itself? At this point, a lot of you are just working on your own items. We are trying to get you up and going and ready to go. So I'm gonna do this, add item. Edit. So reconfig for 2814. And then we'll just, anybody having any troubles with any of the other labs that were giving you problems? I'll be honest with you, I've been trying to do, I've been reading up on the wireless stuff and not doing very well in the wireless quizzes. Because a lot of the wireless stuff is like trying to figure out signal to noise ratios and signal strengths and those types of things.
The RF math.
Yeah.
That's what tripped me up in that other course I was taking. I still don't fully understand it, but I'm getting better. I
do know that, what is it? 3 dB is a 50% increase, and 10 dB is a 100-fold increase. I believe
100%.
Yeah, and so -3 is half loss, and -10 is, was it 90% loss? So, yeah, I'm struggling a little bit with that myself.
Well, for me, it's converting dBi to dBW, is it?
Yep.
Or watts, converting dBi to watts or milliwatts.
The good news is I don't think a lot of that's going to be on the exam. I think the basic concepts is what we need to know, but yeah, it's a little bit aggravating. So what I've in our listing, it doesn't show anything that in depth, but just be aware I did put those pre-configs for the switches into each one of those, and I will fix my own files here so that I have that taken care of for any future CCNP class. So any questions? That's all I've got for today, folks. Hopefully, I'll stop any questions. Not, I'll stop recording.